All right, guys, so I'm going to go over your packet for lesson 2.1. So just again, when you're dealing with these graphs and in standard form, we're going to be using Desmos for a lot of this. So there's some key features that are pretty easy to find just by looking at the equation itself. And so we'll do that and use Desmos at the same time. So first, let's look at X and Y intercepts. Now, when you look at the standard form equation, it's not very obvious what the x-intercept is. We got to do a little digging, but the y-intercept is super easy. You literally just look at the last number or your C term. It's always the C term, okay? And that would be your intercept. And when it crosses the y-axis, that means that x is always 0, and then you just write down that last term. Okay, so that basically is where your y-intercept comes from. The x-intercept, not so obvious. Okay, so that we're going to go to Desmos for. So break out your Desmos, and you're going to just go ahead and punch in your function there. Okay, and now the graph pops up once you type all this in. Now, the nice thing is that, again, we're looking for x-intercepts, right? So that's these points right here. If you click on them, they stay open so that because sometimes you hover over it and it goes away, but if you click on it, it'll stay there. Okay, so this says -3, 0. Okay, so that's one x-intercept. But if you notice, there was 2, so I'm actually going to write the other one right above it. And it says -0.667, 0. Oops, didn't mean to do that. Right there. Okay, so -0.667 and 0. Okay. So now I want to find, let's see, what it say, the line of symmetry and the vertex. Okay, well, this line of symmetry comes from the vertex, so I'm just going to click on that point right there. There's my vertex. So I'm going to go ahead and write those down. So let's see, negative, I'm going to write a new space here, -1.833 and -4.083. Okay, so I wrote that right over here. Okay, so just remember that vertex tells you what your line of symmetry is. It's basically just the x value of that. So it's just -1.83 or 33. Okay, so then it just asks you to basically sketch that. So we got all that important information. Now we can just kind of sketch it out. So first we're going to go plot the vertex. So -1.8. So that's probably like over pretty close to -2, and then we go down, let's see, to -4, right? So just a little bit past -4, so about right there, right? Doesn't have to be perfect. Okay, then I got one x-intercept at -3, 0. The other x-intercept is -0.6, so it's not quite -1. It's a little bit before -1, about right there. Okay, and then we have our y-intercept of 6, 0, 6. Okay, so you just do your best to make a nice U. Always have a little curve there at the bottom, and then bring your point up to make sure it crosses to the y-axis, and then there's your graph. Okay, so this next one, just again, remember that I'm using different equations, so this is not the ones in your packet. So here, again, now we have a graph in vertex form. So remember, vertex form makes things really easy to find that vertex. Now remember, if it's inside, when you're looking for that x value, remember you switch the signs, it's the opposite. So if that says +1, then your x value is -1. And then that doesn't change, that stays as -4. So only the one inside the parentheses here with near the x is that one that actually flips. And then remember I told you, just like here, your line of symmetry comes from the vertex. So that would be -1. Okay, so the other thing I would like to include that I forgot to include here is a line of symmetry. Okay, so I'll do the same thing down here. So first we're going to plot our point at -1 and 4. Okay, and then I'm going to do the line of symmetry. Okay, but I want to know where it crosses the x and y axis, so I'm going to go ahead and use Desmos to figure that out. So I already typed it in here, and again, I'm looking for where does it cross. You can see it crosses there at 0, -1. There's an x-intercept, another x-intercept. So here, let's start with the y-intercept at 0 and -1. Okay. And then we've got a X-intercept here at about 2.1, 2.2, or negative 2.2. Okay, so about right there. Okay, and then right here we've got it at positive 0.15, or about 0.2. So it's a little bit right after 0 right there. Okay, so I've got all my critical points now, and I can just draw my nice U. And again, I just want those X-intercept. I want all those intercepts, X and Y, and then my vertex, and then I can complete my graph. Okay? Okay, so in this problem, your friend is not allowed to use a graphing calculator. So in other words, we're not allowed to use Desmos. Explain to her how she can make a good sketch of the graph of the function 2 times x plus 3 squared minus 8 without using a calculator and without making a table. Be sure to explain how to locate the vertex, whether the parabola opens up or down, and how it's shaped. How its shape is related to the shape of y equals x squared. Well, first of all, y equals x squared is a graph that is like our base graph. Like it's the one we start with. It starts right in the middle of the coordinate plane, right at 0, 0, kind of goes up. And it's like the base parabola for all different parabolas, right? So basically, how does this graph compare to that one? Okay, so the function that we're going to use in this problem, because remember, we're not going to use the same one, is 2 times x minus 2 minus 2. Okay, so first thing is we're not calculating anything, or we're not using algebra to calculate anything. We're just looking for the vertex. Well, the good thing is it's in graphing form, okay, or vertex form, whichever you want to call it. And we look at the h value here, and we always change it. It's always the opposite. So if that's negative 2, the h value is actually positive 2. And the k value stays the same. So that's negative 2. So there's your vertex. That's where the middle of the graph is. Okay, then does it open up or down? Well, we know that the a value tells us that, and if it's positive, it opens up. So we know that this opens up. Okay, and then the last part is how does the shape relate to the normal graph, the base graph of y equals x squared? Okay, well, the way we know that is by looking at, again, at the a value. If your a is greater than 1, it's going to be narrow or skinny. Okay, basically the bigger that number gets, the skinnier the graph gets. Okay, so if it's a is less than 1, okay, and actually I should say the absolute value of a, because it doesn't matter if that's negative or positive. It's just when the number gets smaller, it's going to get wider. Okay, so in this case, it's bigger than 1. So that means it's going to be narrow. Okay, so it's just going to be a skinnier graph. So if I was to kind of like do a quick sketch of this, because again, remember, we're just looking at a quick sketch. It'd be over 2, down 2, and it'd be going up, and it's kind of skinny. Sorry about my kids in the back. Okay, so that's a quick sketch, right? But now your friend also needs to figure out the x and y intercepts. Well, in order to do that, we actually have to do a little bit of algebra. So what we're going to do is we're going to take our equation and we're going to expand it out. So we know that squared right there means that we have 2 of these x minus 2s. So I'm going to write that twice. X minus 2, a lot of 2's, right? Okay, so now what I want to do is multiply first x minus 2 times x minus 2. I'm going to use the box for that real quick. So my 2 by 2 box. Yes! Okay, so then x times x is x squared. Then minus 2x here, and then positive 4 there from negative 2 times negative 2. And so what I'm going to get is x squared there. Add up the like terms, negative 2 and minus 2 and minus 2, which would be negative 4x, and then plus 4. And then minus 2 there. Okay, so now what I want to do is distribute this 2 to all those terms. So that's 2x squared, then minus 8x, and then positive 8. And then now I can subtract that 2 on the outside. So 8 minus 2 is 6. Okay. So now I'm ready to start factoring this out. But before I do that, I've got it back in standard form. So there's my A, there's my B, there's my C. And remember, your y-intercept comes from the C value. So I can write that over here once I have it back in the standard form, 0, 6. So there's your y-intercept. Okay, so now let's find the x-intercepts by trying to factor this. Now what I notice right away, guys, is that notice there's a 2, an 8, and a 6. What can divide in both 2, 8, and 6? Well, 2. So it's a common factor. So what I'm going to do is I'm going to do factor out that common factor. So as a 2 is a common factor. So in other words, 2 times what gives me 2x squared? Well, just x squared. 2 times what term will give me negative 8x? Well, negative 4x. And then 2 times what will give me 6? Well, it'd be 3. So it's basically almost like distributing, but going backwards. So I'm trying to figure out what number would I put here times 2 to get me that. Okay. So now let's factor. So the 2 stays there, doesn't go anywhere. But now we're going to work this out. And I'm going to do that with the x. So, and again, when you have the trinomial or the 3 numbers inside the parentheses, don't worry about this 2 when you're doing this kind of factoring here. Okay, so there's your a value, which is 1, and then your c value, which is 3. So 3 goes on top. And then there's your b value, negative 4. So what 2 numbers multiply to 3? Well, the only ones I know are 3 and 1. But it's negative 4, so that means both of these should be negative. And that works because negative times negative gives me positive 3. Okay, so now remember, if that first a value is 1, I can go straight to these factors. If it wasn't 1, bigger than 1, then I'd have to use the box as well. There's -1. Okay, so now I can figure out my x-intercepts. Use the zero product property, and I know that from here I get 3, and from here I get 1. So my x-intercepts are 3, 0, and 1, 0. Okay, so you can do that with your own problem. Okay, so now on the back side of your, move my camera a little bit. Back to your homework. So we got to graph this equation. Now I want you to notice this just only has 2 terms. It has both x terms, right? So we're missing that c term. Okay, but it's still in standard form because we have like x squared plus a term with x. Okay, so let's do, sorry, I'm losing focus here. Let's do x squared plus 4x. Okay, now the easiest thing to find here is your, let's just lock this in so we can't lose focus here. The easiest thing to find is the y-intercept. Well, remember that this is your a value, this is your b value, and the c value is not there. And the reason it's not there is because it's actually 0. So there's your y-intercept. It's at 0 and 0. Okay? So anytime you get an equation that looks like this, it's just going to be 0, 0 for that y-intercept. Okay, so, but to actually find the x-intercepts, let's take that 0 out. Okay? So what we're going to do is we're going to factor it, just like if we had 3 terms. And the good thing with 2 x terms like this, since they have x in common, we can just factor out an x, kind of like when we do the box, or just a 1 by 2 box. And you figure out, okay, what is the common factor here? Well, it's just x. And then x times what gives me x squared? Well, it's x. X times what gives me 4x, so that's just 4. And you could actually use this kind of box to factor back when we did that last problem. Here, when I factored out that 2, I could have done that same thing, set up the box and then factor out the 2 to figure out the this part, this x squared minus 4x plus 3. Okay, so anyways, so there's my factors. So x times the numbers on top, x plus 4. Okay, so now, if you remember when we factor this, we use the zero product property, and if we just have x here, the first one is 0. That's the first solution from that, right? And the second solution, using the zero product property, would be -4. Okay, so there's our x-intercepts, but we just got to write them in a coordinate form as a point, right? So that's the x value of each of those points, 0 and -4. And then the y value is always going to be 0 for an x-intercept. Okay, the last part we got to find is the vertex. So to find the vertex, we're going to use the fact that we already know the x-intercepts, and usually the vertex is right in the middle of that. So -4 and 0, 0. And notice how the x-intercept and the y-intercept are the same point because they both cross the y and x-axis at the same time. So that means my line of symmetry goes right down the middle of the x-intercepts. So somewhere along this line is going to be our vertex. So that means the x value of the vertex we already know is -2. So if we know the x value, all we got to do is plug that back into your equation and find the y value. So find the vertex. Okay, so we're going to plug in -2. Okay, so -2 squared is +4, because -2 times -2. And then 4 times -2 is -8. 4 minus 8 is -4. So there's our y value. Okay, so we can plot that now. So down -2 and -4, and there's our graph. We only need those 2 points, or those 3 points. So it goes up and to the right, and I make a little curve and goes up and to the left. Okay, and that's it. Okay, so now on this one, okay, so sketch a graph of each parabola and find the x and y intercepts and the vertex. Okay, the great thing about this is, remember, if it's in standard form, makes it easy to find that value, right? Okay, so let's actually write out a different one. Let's do y equals x squared plus 6x plus 8. Okay, so that's the one we'll use for this one. Okay, so the y value, the y-intercept's the easy one with the standard form, so we know that's 0 and 8. Okay, but the x-intercept and the vertex, we have to do a little bit of work to get there, to find that. Okay, so first we want to factor it.
What quarter are you in?
Okay, and remember we have an a value of 1, so we can just do this first step and find the factors. So we got 8 on top, 6 on the bottom. What two numbers multiply to 8, add up to 6? So that'd be 4 and 2. So this just be x plus 4 and x plus 2, meaning that the x-intercepts are -4 and -2, because remember, zero product property says that they're opposite. So once you factor it, then you change the sign. But you don't change the sign while you're factoring. Sometimes people make that mistake, because as they're factoring and putting it here in the parentheses, they switch the sign here, and then they accidentally switch the sign again. But don't switch the sign until you're actually looking for that x-intercept, okay? So then that means -4 and 0. And I probably need an extra parentheses here because there's actually 2 x-intercepts, not 1. So -2, 0. Okay? And then the last part is going to be the vertex. Okay, well, I can do this. What I can do is, like I did in the last problem, is first let's graph it. So -4, -2. Okay? And then we have 0, 8. So 0, 8. Here's a y-intercept. So then if these are the 2 x-intercepts, that means that it's right in the middle of that. The nice thing too is that because parabolas are symmetrical, if this point is 3 squares or units to the right, that means the other point on this side is also 3 units to the left. So that's the nice thing, is that with parabolas, is once you know the line of symmetry, that's why it's called the line of symmetry, is that they're the same on both sides, right? So now I got 5 points and make an even more accurate graph. Okay, so I know that my x value is going to be -3, because that's the value in the middle. So I'm now going to plug that into my equation and figure out the y value. So -3 squared, and then plus 6 times -3, and then plus 8. Okay, so 9 squared, that's 9. And then 6 times -3 is -18, and then plus 8. Okay, then we're going to do 9 minus 18, it's -9. And then plus 8, that's -1. So there's our vertex. 3, -1. Okay, and then I can complete the graph. Make a little curve down here, kind of slope it up to the right, slope it up to the left, and there you go. Okay, so now with this one, now here, again, we've already factored. It's already in a factored form, so I don't have to use the x. I can just kind of find the x-intercepts right away. The only thing we don't have is the y-intercept. So the easy thing we can find here is the x-intercepts. And remember, zero product property, so take the opposite. So we have +4, 0, and -2, 0. Okay. Just realize I'm giving you guys the answers. Okay, but that's okay. From this point on, I don't care. All right, so now what we want to do is we're going to have to multiply this back to get it back in this standard form, okay? So let's set up a box maybe over here. I don't care where you put it. All right, so we got x minus 4 and then x plus 2. And again, we're doing this. We got to multiply them because in order to get that y-intercept, we need to have it in standard form. Okay. All right. So now we have x squared, y equals x squared. And then -4 plus 2, well, that'd be -2. And then -8. Okay, so there's our y-intercept at 0, -8. Okay, so maybe you can finish the rest of the problem. So try the rest of the problem on your own, okay? So we got the x-intercepts, 4, 0, and -2, 0, and the y-intercept right there. So now we got to figure out that point in the middle, right? So just to kind of get you started, there's the line of symmetry, because remember, it's the line in the middle of the x-intercepts. Okay, so that means that our vertex is at 1. So plug that 1 in, figure out the y. Pause the video, see if you can figure it out on your own. Okay, so let's plug it in. So 1 squared minus 2 times 1 minus 8. 1 squared is 1. Then this is -2. 1 minus 2 is -1 minus 8 is -9. So we get -9 here. Okay, so we got 1 and -9, so it's right below that y-intercept. So I'm going to reflect this point over to here, because remember, you can kind of like reflect it over. Since it's 1 to the left, that means the other point is 1 to the right. Okay, and then make my little U, going both ways, and boom, done. Okay. All right, so now let's take a look at these problems down here. Okay, so for these problems, I was kind of taking a look at them. I noticed that if I tried to do the x here, I'm just going to show you. I put -9 there, -6 here, and try to think of two numbers that multiply to 9 and add up to 6. Well, the only ones that come close would be like 3 and 3, right? In order for that to be negative, that means only one of these can be negative, right? But then that will never add up to -6. So I know it looks like it would work, but in order for it to work, this would have to be a +9. So this actually doesn't work. So we actually need the quadratic formula for this case. And so it's okay, like, especially when you're working with these types of problems, use Desmos, okay? So these last couple, we're gonna like use Desmos. So let's go ahead and make another one up. So let's just say x squared minus 4x minus 2, all right? And let's see what we come up with. All right, so let's go over Desmos. I got rid of this one. Okay, so let's do x squared and then minus 4x minus 2. And I'm going to get all those critical points. There they are. Remember, you can just click on them and they'll all show up. So there's my 2 x-intercepts. So I'm writing these down right now. So you go ahead and write, if you're working on yours, you can write yours down. So 2 minus 6. And then the y-intercept is 0, -2. And then I'm going to round these. So this is let's round it to the nearest 10th. Okay. So that 4 is not going to round this 4 up. So it'll be -0.40 or -0.4. -0.4. And then the other one is going to be 4.4. Positive 4.4. Okay. So I wrote all that down here. Okay, so you can take a moment to pause and go ahead and graph yours, and if you want, and then figure out where it's at on Desmos. So first, let's start with the vertex. So we're going to go over 2, then down 6, right there. Then the y-intercept, 0 and -2. Okay, so now 4.4. Well, that's just a little bit more than 4, somewhere in the middle, almost 4.5, right? And then -0.4, which is right after 0. So it's about right there. Okay, so let's make my line of symmetry. Okay, so remember, like I told you, I can reflect this point straight over to here. So let's put that here just to help with making that graph, and there's 5 points. So now I make a little U at the bottom, kind of come up to the right here, and do the same thing on the other side. Okay. Okay, so now we can do the same thing over here, pretty much. So basically the way I just did that one, do the same thing here. Okay, so just look at this one in order to figure this problem out. All right, and that's it.